Any learning, by the way, is good. We had a lesson about trees and how they impact the environment. Doesn't have anything to do with software development for digital manufacturing.
But you never know what's going to strike, like
Exactly.
Inspiration or motivation may come from some of the most unexpected places. Today I speak with Zvi Feuer, SVP of Manufacturing Engineering at Siemens Industry Software. Like many of our previous guests, Zvi comes from an engineering background before he pivoted to marketing, business development, and project management in the same industry. Whether in business or engineering, it can take several moving parts to get results, and for Siemens, teamwork makes the dream work. How can bridging the gap from engineering to management be productive while keeping both sides in mind? What does it take to spot a trend, take charge of it, and ensure its long-term impact? And what has Zvi learned since his start as an apprentice, growing in his career path, continuing to value education and new skills along the way, and creating new learning opportunities for aspiring engineers on his team? This is my conversation with Zvi Feuer. We live in a time where design and technology touch every aspect of our lives. But where did it all come from? Who designed it? How was it built and brought to market? What will it look like in a year? 2 years? 100 years? From the phones and smartwatches that help us in our day-to-day to the cutting-edge spaceships and 3D printers that are leading us into the future, modern design is constantly shaping the way we work, communicate, problem-solve, and play. And every new design, big or small, starts with an idea and a bill of materials. I'm Magenta Strongheart, and this is The Bomb, where we talk to leading innovators in the tech world and celebrate the transformational power of design. Welcome, Zvi. I'm so excited to have you on The Bomb. Thank you for taking the time today. Zvi Feuer is the Senior Vice President of Digital Manufacturing for Siemens Global Digital Industries, and I would love to talk all things manufacturing with you today.
Great. Thank you for having me.
Yeah, so I think a good place to start, we had discussed a little bit earlier, why is manufacturing so important at this time, especially in the US?
So I think in the last 20, 30 years, a lot of the manufacturing that was very well entrenched in the American society was pushed out into Asia, into China, and a lot of good people that do not have a degree, had a decent job in manufacturing, lost their job, and became actually very poor. And, manufacturing is a very good way to kind of increase the balance between rich and poor. And we just lost this opportunity. Another thing that happened is that you can do a great job in designing products, but if you don't have manufacturing capabilities nearby, you're missing one big part of the overall life cycle of product delivery to market.
Absolutely.
And this, again, created a situation where America lost its competitiveness. One area which is very, very visible is semiconductors. But there are other areas where America was really number one. And the opportunity to bring back manufacturing, to do onshoring of manufacturing, I think is a fantastic opportunity, especially for a company like ours, where we are not only doing software, but we also do automation and we do logistics and many other elements of the manufacturing end-to-end process.
The full process, yes.
And this creates, I think, a lot of opportunities for people to gain a job. We should also remember that it's a fact that there is a very small portion of the population that goes to study in the university. There are a lot of good people that need a decent job and are willing to learn a trade, like, operate a CNC machine or work near a 3D printer, or do some kind of a logistic job on the shop floor, or prepare the tooling for a production cycle. These people, if they don't have the place to do it, they are losing their livelihood. They go back to services. Their wages are very small, and we all lose. We lose good people, we lose productivity, we lose production, and we lose the opportunity to close a little bit the gap between the rich and the poor.
Yes, definitely. And something I think that's so awesome about these roles that you're discussing, these positions within manufacturing, is oftentimes they can also be a stepping stone to further engineering education or opportunities in management higher up. So for folks that aren't going to university for this specific skill set, they're able to be trained in some of these, positions you mentioned, operating a CNC, really trade-based, roles, and then they're able to grow from there into these companies. So it is a huge opportunity. I agree.
Yeah, you see in Germany, for example, where industry is about 20% of GDP, there is this tradition of apprentice. You don't want to study in high school, you go and become an apprentice. You work 3 days, you study 3 days. After a certain period of time, you work really seriously, you start to understand that you can do more. Many people elect to go and do a university degree. And then you see these people are really practical engineers. They're not theoretical guys. They really work on the shop floor.
Yeah, they're hands-on.
When I was 16, my uncle had a factory for PCB. When you showed the PCB today, I got excited because I remember the days where we were actually printing, on a copper surface, a PCB. We had a special drilling machine. That's why I asked you.
Yeah, how did we get the holes in that board?
Yes.
Yeah, so you've been familiar with the process from
but I wasn't an apprentice. I just worked at the summer vacation. My mother said, you need to do something with your hands, otherwise you are going to get crazy at home.
Yeah.
So
absolutely,
go and do something. And that's when I actually started to fall in love. And I did my own PCB and built my own radio. I was a radio ham, and so it was really a good training for the future. So when somebody talks with me about electronic manufacturing, I know what he's talking about.
No, which is so great for you to be able to understand at that very foundational level. And I think that brings up a good segue to something else we wanted to discuss, which is kind of how to keep individuals, especially on your team, all over the world, involved in kind of continuing to learn, continuing to get hands-on experience, continuing to think creatively. And you were telling me about some of your team hackathons, which I was really interested in and would love for you to share with our audience how often you all do those and some of the topics that you've covered with those.
A couple of years back, we did when I took over digital manufacturing, I thought about the need to shake the organization and put some more innovation into it. I'm a believer that without innovation, we're going to continuously improve the mousetrap. The product is going to become a little bit better, but we're not going to break through to something new.
You're not going to make leaps and bounds.
Yeah. And at that hackathon, we started to talk about additive manufacturing, for example. And to be honest with you, we were very naive. We thought we have CNC technology. What's the big issue? Instead of, shaping off chips, we're going to add material and, use a laser to. And apparently this was the beginning of an additive manufacturing journey for Siemens, which started in our hackathon and ended in an end-to-end solution that starts at early engineering and goes through the whole process up to the delivery to the customer.
Wow.
And this is really amazing because we have seen big developments over the years, and we are still not at our peak. So there's more and more work to be done. And as we peel more and more of these layers of knowledge, we understand how little we knew at the beginning when we started this. Another area that was very interesting for us was virtual reality. We have a very strong capability to program robots and to develop very complex robotic cells for automotive assembly. And we thought how good it could be if we could immerse ourselves into the cell using VR. And we looked around, there was no VR solution. And one of the teams in this first hackathon that we did invented something on the fly in 3 days, using some goggles that some of the guys had at home from a video game.
Wow. It puts some other development cycles to shame when you say 3 days, right?
Yeah, but look, it wasn't a product.
Of course, but it's the prototype. It's the initial.
Maybe 10% of an MVP.
But that's important still.
And yes, this started a whole business for robotics. VR in robotics. Another team did some work with AR, augmented reality, and so on and so forth. And this kind of became something that we started to look at, and we said, what our challenges are for the future. By the way, one of the things that we wanted to do is we wanted to make sure that if somebody wins, not everybody, but we had many teams, if one of the team wins, we give them some time to make this thing happen.
To really realize it.
To realize it, exactly. So in additive, we realized this thing. I was totally naive. I thought we're going to do something quick and dirty and we're going to have a product. It took 2-3 years to just bring...
That sounds more like it, yeah.
Bring a solution to life. On VR, within 6 months, we had a decent solution which we could sell as an add-on to our robotic solution.
So I'm curious about the VR solution. When you talk about VR working with robotic arms, you said, right? And so what's an example of an application in this? You were mentioning automotive manufacturing.
Collaboration, for example.
Being able to do remote collaboration, right?
You're in teams. BMW in Germany, and you design something which is a big robotic cell, which is a standard cell, and you want to make sure that in Spartanburg in America, they use the same cell. So you can use VR and you can immerse yourself into the cell that was actually copied, maybe changed a little bit because some of the circumstances are changed in Spartanburg, but you want to immerse yourself from BMW and from Germany, and you want to make sure that you take a look at the cell and you validate that the cell that they have over there is similar to the one that you have perfected in Germany, because otherwise the cars in America, the cars in Germany are not going to look the same.
Of course.
So that's one example. Another example is employee training.
Yes, I've seen this especially in medical, like surgical processes, like being able to train surgeons in, remotely, and also without having, to have real humans, to test on, being able to do a simulation through VR or AR in order to learn the kind of intuitive motions and that sort of thing.
So here I think you're going into a very interesting domain, because here we can combine actually some technology coming from Siemens Healthineers with additive manufacturing, and then we can go into AR, VR. How do we do it? Let's say that there is a patient, he has a tumor on his liver. We can scan his body, turn the scan into a 3D model, print a 3D model of the liver with the tumor, and then
practice and figure out what to do.
And practice the surgeon
in a much lower risk environment.
Lower risk environment, and have somebody maybe at home or maybe in another city in America who is a specialist in this type of surgery, guide the young surgeon in the hospital, let's say here in Pasadena, who is maybe less experienced, maybe just out of university, how to do this operation in the most professional way.
Absolutely, which is so incredible to think about just how far that technology has come over the years.
So we are looking more at the manufacturing side of AR, VR, but this is one area. So hackathons is something. Then there is another program which is called 10%. We have a 10% board. People come on, they make a kind of a pledge or a presentation about their idea, and they get 10% of their time for a period of 3 months to develop a prototype of their idea.
Wow, staff members, people on the team.
People on the team.
Yeah.
Hackathons could be local hackathons, could be global hackathons. In some cases, the hackathons are really done across the board. And within these hackathons, we bring in also startups from the outside. So at least I'm trying to embed ideas from the outside, because I believe that not all the smart people work in Siemens.
Absolutely. I think that's a fair belief. And I think that it makes a lot of sense, to have these different perspectives in a room. That's really when I think innovation happens. And when you can have someone that, is thinking from a little bit of a different area, a different angle from their own background or expertise, makes all the difference. Because it's hard not to start to when you're working on the same teams over and over again, to get a little insulated and start to think very similarly, right? So you need the mix of perspectives to really make a dynamic space for collaboration and innovation.
Yeah.
Absolutely. We'll return to my discussion with Zvi after a word from today's sponsor. When we get back, Zvi and I will go over the newest developments in augmented reality, how Siemens is putting those to work, and making better teams through its virtual reality training simulations. Are there other innovations that cut costs, won't cost an arm and a leg, and possibly make new ones through Siemens developments in advanced 3D printing? We'll be right back. Welcome back to The Bomb. I'm Magenta Strongheart. We'll get back to my conversation with Zvi Feuer, SVP of Manufacturing Engineering at Industry Software, on how the pivot to work from home turned to work from anywhere. Does the next breakthrough in tech, engineering, and design have to take place on-site or even at an in-person roundtable? What did Zvi and his fully remote team face in designing, prototyping, and demoing works in progress? And how can e-learning come into play and work for Siemens' new Learning Days and Innovation Ecosystem programs? Let's get back to our conversation. And so another really awesome example that you were showing me just before our conversation that I think is an amazing tribute to the kind of magic and capability of additive manufacturing was this prosthesis project.
Yeah.
I would love to hear more about how you guys discovered and started to work with this amazing creator and how it's scaled through Siemens support.
So I don't know who approached who, to be honest, but we found this guy who is an amazing entrepreneur, super smart, Eton LaChapelle. And he showed us what he's doing, and he had this vision about maybe going to additive. And we said, yeah, let's do it together. So a team of our from our additive organization combined forces with him. And we started to work together to identify the opportunity. And we came to this idea again, scanning. So he wanted to send an iPad to the family of the person. These are normally kids. Mm-hmm. You know, the problem that he was trying to solve is that the prostheses of kids are changing like shoes. You know, the kids are growing.
They become irrelevant so quickly. A year later or less.
And a decent prosthesis at the time was $80,000.
$80,000, which
and he wanted to reduce the price and make it a little more affordable. So he thought about this idea that he will send the scanners, people will scan the limb of their child, will send the picture or the scan back to his laboratory. And there we have actually given him our software, so he could use NX for additive to design this socket and connect directly into the HP 3D printing polymer machines, print, and then test, and then assemble the whole prosthesis. The prosthesis is a smart device. It has some sensors that sense the edges of the
nerve endings.
Nerve endings of the limb, and they actually can operate the hand of the prosthesis almost like a human operates his own hands.
Again, another incredible technology that's developed throughout our lifetime. And it's interesting to think about just how much more capable, 3D printing and these additive manufacturing methods are for something like this to make custom solutions that are more affordable. Because if you are using a more traditional manufacturing process like injection molding, making the tooling itself, would be thousands of dollars, custom tooling for each process. And so this is totally game changing to be able to switch.
For less than 100,000 units, and especially customized units, it doesn't make sense to do a mold. Actually, 3D printing is the great solution.
Yeah.
We have additional examples with 3D printing about 3D printing for robot fixtures, for example, that need to lift heavy metal parts on the assembly line of automotive, where such a robot is very heavy because the gripper is very heavy, and we managed to change and reduce the gripper from a metal gripper to a polymer gripper.
Really? And it could still manage the weight and the impact?
Yes. Wow. And thanks to our simulation technology, we could assess the strength of the gripper. This reduces the weight of the robot. This has an impact on 100 robots per each body and white line. In each line, there are 700 robots, 800 robots. 100 of them are material handling robots. And with this, we can reduce the energy consumption.
Wow,
so
that's
you
huge.
also improve the
environmental impact.
The environmental impact, the cost. You can use lighter robots, which are smaller, which cost less money, and still do the same thing.
It's a win-win-win.
Yeah. But this was not invented in my organization. They used our technology. This was invented in the field by one of our application engineers. He did a great job together with Daimler-Benz, with Mercedes. And yes, we have this as well. One more story I will tell you, one more thing that I want to do, or I do with my teams, is a learning day.
Yes, which I loved hearing about this. I want us to try to start these at Supply Frame.
So first of all, I'll give you a contact person that can help you.
Make it happen. Love
make it happen. Once a quarter, we stop working. It's always on a Thursday, and everybody needs to take a couple of lessons. There's a whole curriculum of lessons that are available for the people. Some are live presentations, meaning they are done live by people. Yeah. Some are internal trainings that we bring you to talk about the lab in
our design lab.
Yeah, your design lab, or we can bring somebody to talk about any topic. Any learning, by the way, is good. We had a lesson about trees and how they impact the environment. Doesn't have anything to do with software development for digital manufacturing.
But you never know what's going to strike,
Exactly.
Inspiration or motivation may come from some of the most unexpected places. And it's actually reminded me that we used to do these events called unconferences internally, where similarly we would take a day for a few hours of presentations, and everyone needed to present on one topic that they just learned about for the presentation. Because something that can be really effective for learning is to be able to teach what you just learned to someone else, and you really ingrain that new knowledge. And so we were doing this for a little bit, but we got to bring it back.
So we do these learning days. We then do a survey after the learning day. But this is kind of a must participate event where people have to subscribe themselves to which lessons they want to go. We monitor it, we record the hours, we then report it into the Siemens Learning repository.
Right.
And the feedback is fantastic.
That's really great.
In addition to this, because I believe in long life learning, and I think a lot of our people are very technology oriented, you might say even a bit of nerds, I found a very interesting institute called the Power MBA, which is a kind of a university that you can enlist for a sum of less than $1,000. You have about 200 lessons which are available to you. They're all video lessons. You get some homework. And you can do it over a period of 2 years. So if you do one class every evening or every 2 evenings, it's enough. You get the opportunity to meet the most interesting people that you can think of. Because, there's no limitation. You don't need to bring the person to the class. You just record it. So startup owners, VC leaders, founders, technology gurus, people that you read about in Wire or in some of the other TechCrunch and so on. They're all there. It's totally volunteering, right? And we're sending 40 people every year.
Wow.
Not easy with the budget crunches that we have sometimes in Siemens, but we are sending 40 people to participate. And the deal is that if you graduate and you show me the graduation certificate, we pay for it. If not, you pay for it.
Well, that's good external motivation. Very smart. I love that. And I really appreciate that you're so supportive of this long learning and continuing to offer, your employees and your teams this opportunity to learn about new subjects and even become experts through this kind of master's program.
Yeah.
And so we do have to be conscientious of time. Unfortunately, we don't have too much longer, and I want to make sure we wrap it up shortly. We do always have one last question that we all ask all of our guests, which is, what is on your personal bill of materials?
I want to do good. I want us to participate in processes and in development of solutions that not only make money for Siemens, but also do good for society. For example, we are supporting BioNTech, which is the partner of Pfizer in producing vaccinations.
Wow.
So all the vaccinations that Pfizer actually produced during COVID and still produce today are done on our production system.
Wow, I did not know that.
Yeah.
I learned something new. I learned a lot of new things actually in this conversation.
So we are collaborating here with another business unit, a sister business unit in DI, which is called PA, Process Automation. And together we provided a solution within a very short period of time that turned this company from a company that did research and development for Pfizer in Germany to a company that produces millions of vaccinations per day.
Wow.
Per day.
That's
and
incredible.
This is thanks to our software and the automation coming from PA. So I want to continue and do these things where I can say there is a mixture of doing good, of supporting the society, of reducing CO2 emission, making cars run better on batteries, developing prostheses for young children.
Absolutely.
When we talked about Eaton, one of the things that I forgot to mention is that thanks to our CEO, Roland Busch, and Cedric, we managed to secure 500,000 euro from Siemens. And together with Eaton, we went and we donated prostheses for children that were in fact hurt or damaged by the war in Ukraine.
Oh, wow. Yeah. That's really amazing. Well, thank you so much for sharing.
My pleasure.
And I hope that all of our listeners take away, do good and never stop learning, because I think those are both brilliant, things to live by. So I really appreciate your insight today, Zvi, and I'm excited for future conversations. I feel like we're going to have to invite you back because there's a million other things we could cover.
Thank you for a very intelligent and enlightening discussion. Really appreciate what you do here, and thank you guys for supporting and making it happen. And I'll be happy to talk to you again, of course.
That was my discussion with Zvi Feuer, SVP of Manufacturing Engineering at Siemens Industry Software. You can find out more about Siemens, the Siemens Hackathon, and its training resources in the show notes. Thanks for listening, and until next time, let's keep building. If you like The Bomb, don't forget to subscribe, rate, and share the show wherever you get your podcasts. You can follow Supplyframe and Hackaday on Instagram, Twitter, LinkedIn, YouTube, and Design Lab at Supplyframe Design Lab on Instagram and Twitter. The Bomb is a Supplyframe podcast produced by me, Magenta Strongheart, and Ryan Tillotson. Written by Maggie Bowles and edited by Daniel Ferreira. Theme music is by Anna Hogbin, show art by Thomas Schneider, special thanks to Giovanni Salinas, Bruce Dominguez, Thomas Woodward, Jin Kumar, Jordan Clark, the entire Supplyframe team, and you, our wonderful listeners. I'm your host, Magenta Strongheart. See you next week.